Good morning, my YouTube viewers. It is Crystal here. I'm just here because I want to give you a code review. I'm taking a break from the machine learning research papers and the courses, and just doing a code review is just to keep up my Tensorflow skills or my machine learning skills. And so basically, we're working on a community competition that it's in Kaggle, and it's to do with the stock market. The problem statement is you have to predict whether a stock is a long or a short. And basically, my best score last night, I worked on it. I worked on it with Tensorflow, and then I worked on it to remove the columns that weren't from the same distribution, and I got a really low accuracy on that. And then I changed it to remove the columns that had a high correlation, and I got a better score. And so last night when I checked it, I was number 1. And this morning, before I started this code review, I checked it again and I was number 2. So there's this group called ML Buddies that they're working together to improve their score. And so basically that's what people do. Like on Kaggle, if you want to form a team, you can form a team and you can try to improve your score that way. But one, nobody's asked me to form a team. And 2, I don't have the time, because if you want to win a competition, what you have to do is you have to look at everybody's code. If people make their code public, you have to look at everybody's code and see if they've done anything in that code to make the score really good. And I don't have the time to do that because I'm a content creator. So I do the best job that I can do. I do the code review, I do the blog post, and then I just leave it. So that's why I haven't won any competitions. But last night I was number 1, but this morning I'm number 2. Some people came in and beat me. So what we'll do is we'll do the code review on the stock market. You have to predict whether a stock is long or short. So the first thing that we want to do is we want to create our Jupyter notebook. And we're going to create the Jupyter notebook in Kaggle, and it's going to be saved in my account. And after we've created the Jupyter notebook, what we want to do is we want to import the libraries that we're going to use. And so the libraries that we're going to use in this program are Pandas to create the data frames, NumPy to perform numeric computations, and Pandas also does data processing, and NumPy also creates NumPy arrays. OS to go into the operating system and retrieve the files. Sklearn to provide machine learning functionality. Tensorflow to create the neural networks. Matplotlib to visualize the data. And Seaborn to statistically visualize the data. So those are the libraries that you're going to need for this program. And then after you've done that, then what you're going to do is you're going to go use the OS library to retrieve the files. In this instance, we have a train file and a test file, and we have no sample submission. So that means you're going to have to create your own data frame for the sample submission, which I have done at the end of the program. So after we've retrieved the files, what we want to do, sorry. Sorry, I had a phone call. I went and had to turn it off. So what we do, going back to the code review, what we do is we use pandas to read the two files, train and test, and we convert them to data frames. So you can see the train file here, and you can see it's got 39 columns of data. The final column is your target, which is your result. Then we look at train info, so you can see whether the columns of data are going to be object, float, or integer. So you can see that. And then what I wanted to do is I wanted to look at the number of unique values for each integer or object column. So you can see the number of unique values for each one. That was in your train file. Now I want to go through the unique values. So the exchange is Binance, Bybit, Huobi. Okay, hold on, someone else is phoning me. That same person was phoning me, but I've got my phone with me, so if he phones again, I can just turn it off. I get a lot of crank calls. Obviously people are trying to sell you something. They got my number from somewhere. So they keep phoning me to try to sell me, but I'm not interested. So we're going to go back to we're going to look at the unique values for each column that's either an integer or an object. So the one that we're going to be the most interested in is going to be the exchange, because it's got Binance, Bybit, Huobi, and OKX. And the reason why we're going to be interested in that is because the test file is different. Because the test file is different, it's going to cause a lot of problems. So I'm going to show you in a little bit what I did to get around that. We checked for null values. Fortunately, we don't have any null values, so we don't have anything to impute or drop. Then we use describe, so if you want to know the statistics of the data set, you can see the statistics as well for all of the numeric columns. Now we check test, and you can see that the exchange has different values than the train file did. So that's going to be problematic, and that's going to have to be resolved before the program will work. And we look at the very end. We don't have a result, but we have an ID. And the thing is that we don't have a sample submission file. So you're going to have to take that ID and use it for a submission file that you create. What we want to do is we want to see the number of unique values in each column that is either the integer or the object in the test file. So that looks pretty much similar to the train file, which is good, because sometimes it's not. And then what we want to check is the actual unique values. And so you can see on the unique values here on the exchange, you've got BC, BB, OK, HP. So that's got to be changed. So what I did was I defined the exchange, and so in the exchange column, I replaced Binance with BC, I replaced Bybit with BB, I replaced Huobi as HB, and I replaced OKX with OK to get the train file and the test file have the same values in the exchange column. Now what we do is we define our ID numbers, because as you can see in the test file, the ID numbers were the very last column. So test ID equals test.pop ID, test ID. So what you're doing is you're taking the ID out of the test file, but you're retaining that information and calling it test ID to use it later on. So now what we want to do is we want to analyze our target. Target is quite often called your label. So target equals train.pop result. And then we're going to use Seaborn to create a histogram of the target. So you can see we have a class imbalance. Okay. So now what we're going to do is we're going to check to see if the columns of data in the train file and the test file are from the same distribution. And what I found out when I did this, almost all of the columns of data are not from the same distribution. And as a result of that, I could not drop it because it really, whenever I tried to drop it, you only had 6 columns of data instead of 38 or 37. And then in addition to that, you didn't get a good accuracy. So even though the columns, most of the columns were not from the same distribution, I had to leave them as they were. So that's one thing that you can check whenever you're studying, when you're working on a program. You can look and see is the column from the same distribution, and if the column isn't from the same distribution, you can drop that column and see if it improves the score. But as you see, I couldn't do it in this instance because most of the columns were not from the same distribution. And after I checked if the columns were from the same distribution, I had to encode all of the columns that were of D-type object. And so the train column, I used Fit Transform on the ordinal encoder, and the test column, I just used Transform. And that's why we have to make sure that on the D-type object, all of the values are the same between train, well, not values, but all of the categories are the same between train and test. Otherwise, the encode label ordinal encoder won't work. So now that we have encoded the data, what we're going to do is we're going to create a heat map. And this using Seaborn. So core equals train.core, sns.heatmapCore. And you can see this is the heat map that we've created. And so you can see that it looks like there are a few columns that have a high correlation. So we're going to have to look into that. So you can see core here. There's a lot of columns, so it's hard to see which ones have a high correlation. But what we're going to do is we're going to delete the columns that have a high correlation. And when we do that, you can see that it's dropped about 10 columns that have a high correlation. So we're going to drop those columns that have a high correlation. And if you want to, if you want to like keep the columns in there and see what happens, you can do that. You can see, do you get a better accuracy when you don't drop the columns? But the thing is, it's like when you have columns that have a really high correlation, then that creates a redundancy and can introduce noise into the system. But it's something that you can check to see which works better, removing the high correlated columns or leaving them in there. So after we've dropped the columns that have a high correlation, we're going to standardize it. So all of the data is going to be standardized, and we're going to use sklearn standard scalar to do that. So it's going to be Scalar Fit Transform for the train column, and it's going to be Transform for the test column. Now we define our x and our y variables. Your y variable is your target, your x variable is your train, and your x test is your test. And now we're going to use sklearn's train test split to split the data set into training and validation sets. Now what we're going to do is we're going to define the class weights. And we're going to use sklearn's class weight utility to do that, to define the class weights. Now what we're getting into is we're getting into the neural network part of the program. So we're going to import Tensorflow and its associated modules. You can see that we're using Tensorflow 2-12. Now what we're going to do is we're going to define model. We're going to have a sequential model. We're going to call it stock market. And we're going to have 50 neurons in the hidden layers. And you can see that for the first hidden layer we have ReLU. The second hidden layer we have Swish. And the third hidden layer we have Sigmoid. Now what we're going to do is we're going to compile the data, and we're going to use binary cross entropy as the loss function, atom as the optimizer, and accuracy as the metrics. We're going to set up callbacks, which is going to be early stopping, and we're going to set up epochs as 10 because it did take a long time to train this data. So I just set it up for epochs because I was in a hurry, but you can set it up for more if you want. And so we set it up, we fit the data into the model. So history equals model.fit, xtrain, ytrain, epochs equals epochs, validation data equals xval, yval, verbose equals 1, callbacks equals my callbacks, class weights equals weights. So it ran it 10 times. You can get it to run more if you want it to run more. And then what we used is we used Matplotlib to graph the accuracy and the loss. And so you see that we have an accuracy in the 80s. We evaluated it, and you can see the accuracy is in the 80s. We predicted on the validation set, and when we predicted on the validation set, we put it on, created a histogram, so you can see that there is a class imbalance there. Now we put it on a confusion matrix, so you can see that the confusion matrix isn't that great. And one thing that perhaps I should have done is I should have set it up for accuracy, but you can see the accuracy here is being 86. Now we're going to predict on the test set. So, and then after we predict on the test set, we create a histogram of it, and you can see that there's a class imbalance. And then we prepare our submission. So when we prepare our submission equals pd.dataframe, ID equals test ID, result, prediction, submission, and then we're going to create it. We're going to turn it into a CSV file. And so then we're going to, after we turn it into a CSV file, we're going to read the CSV file, and you can see that this is what we're going to submit to Kaggle. And when we submitted it to Kaggle, we had a 73%. So come over here to stock market predictions. Now it says I've got no internet, and I've got no internet because I got 2 calls. But I do have internet. It's just that I do have internet. It's just that I'm going to have to try to sort that out as well. I did have internet until I got called twice. And then when I got called twice, it blocked off the internet. So unfortunately, I won't be able to show you what the leaderboard is. But before I made this video, I was number 2 on the leaderboard. And last night I was number 1 on the leaderboard. So I'm going to go ahead and close this code review because I can't show you anything else since my internet has gone down. But I would like to thank all of my subscribers for supporting my channel and bearing with me while I got 2 phone calls. And if you like my video, please like, subscribe, and share. And thank you for watching my video. If you want to be notified whenever I make a new video, then please tap onto the bell button next to the subscribe button. And I look forward to making more videos for you in the future.